is funding actual houses made of bricks to be built in a village. So they're taking it one house at a time, and the people in that village are building these homes, and they're actually laying the bricks out in the sun.
Curing
Are
it.
they?
Yeah.
They're not using this model, but they could, because they're going the old-fashioned way of doing bricks. They're also taking exhaust when they're actually in the hut, and then laying them out. So something like this could really be implemented and taught to them, because they have the will and the intention. So it's just
Correct.
getting it in the hands of the right people. Anyway, and Pratod, if you could just quickly speak on what Matt and I and yourself talked about yesterday on why the farmers may not adopt this, even if it's in front of them.
Yes. So that is one reason how I got introduced to open source ecology. So in India around 2011, I was reading few news where there were farmer suicides and there is a death cycle that they are into. With the seed cycles that they have, they cannot get their own seeds. Even if the crops are destroyed, they have to buy more seeds, which are genetically modified. They have to fire pesticides, fertilizers, blindly not knowing how much amount should go in, and that led them to a debt cycle, and many farmers were committing suicides. And that got to me, and that led to me to find out exactly how this can, if there is a change that can be brought to do something about this. And I found open source ecology to see if this can be used. But again, this idea of open source ecology is more about building the machines and which are used in the one of the industry, which is the agriculture industry. Now coming back to the question where why farmers won't adopt this thing, because they are not going to build this. They don't have the expertise to build these machines. The farmers only know how to till their land and produce good harvest. So if there is enough awareness about this, where people would come in together, let's say for an example, so that this experiment was done, I think, in the South American country, where a bunch of people came together in a remote place, built the pre-press machine, and at the same time, the bricks that were cured out of it, pushed out of it, were used to build a small house on the farmland that they had, which benefited the farmer whose land it was. So again, it all depends on the interests that people like you and me have. But for a farmer, they cannot build this. There has to be someone who can build it for them, and how they can access it is maybe by like an Uber model or a shared economy model, or even a non-profiteering model where there are people across the world who can fund it, and like a crowdfunding stuff, and build it and give it to these people who are actually in need but cannot afford it. Does that
And you
answer
also
your question, John? Yeah.
John Deere, that everybody uses John Deere tractors, and that you would have to really help them trust that if this machine is down, they can fix it. And instead of, they trust John Deere to take care of that because they know the cost of the disruption in business and what they're trying to accomplish if it does break down. And I will say too, with brick homes, when we're discussing bricks, one of the largest reasons for childhood mortality, especially in these villages in Africa, is because the roof, when it rains or storms, the roof falls in. So having a brick home with a stable roof is very important.
Mm-hmm, mm-hmm. Yes. But again, who is going to build these homes? Can they build these homes? No. They don't have the resources. They don't have the technical know-how also, or like how you build up a column and how you build a roof. So it is important for us to understand that there are people who are in need of these kind of stuff, but then there is an entry barrier for them. But again, with the digitization way, so in India, I have seen this trend in last just 3 years. Since 2016, there was a launch of this telecom giant Geo, which you might have read it. They have made internet almost free, you can say. I have 2 GB a day I can use on my mobile phone, and that is nothing for me because my internet consumption is huge and I have broadband connection and all. But if you look at the rural places where this internet is penetrating through mobiles, there are farmers who have access to this information now. So there is a possibility that people can group in together in these villages, and maybe people like me can go and give them the expertise, make those machines, and teach them how they can service it by themselves. Now, remember again, when you're talking about John Deere is the only people who can service your, or the local mechanics can service your tractor or the machines that are built. But you have to depend on John Deere for the products as well. And again, there is a planned obsolescence in every product. I, I mean, you can research more about it, but it's not always true. But again, the corporations want you to buy more. So if it is a self-reliant machine where your components are modular enough to be fixed, swapped easily, you can fix it by yourself, service it by yourself, and that is something that awareness can be created, and this actually can fuel an enterprise idea as well. In the main parts of, at least in India, I see the rural places are in need of these kind of machines, but they also need, they are hungry for information and they want to know how they can harvest more, how they can grow more organic food. Aquaponics is taking some interest in rural places because of the climate change that is happening. So I think I mentioned yesterday, Sean, that in last year in the rainy season in India, which is from July to September to October, at 3 4 months, there was, due to climate change, there was a lot of rainfall in the regions which had hardly some rainfalls every year, and everything was flooded, from the farmlands to the cities, urban cities to the rural places. So their crops were destroyed, and now they want to build their own land again. So again, this is all and just an idea that we are working on. I'm just introducing these guys so that you can fuel it further, maybe discuss it more within your networks. We can also have more sessions like this, but there has to be an awareness. So Kalpesh, who has joined with me, was not aware of open source ecology until I explained him what it was, and he just got hooked to it. With visual design sprints also, it is something like that. So it's more like more people like us, if we connect more and brainstorm. And the most important thing is, if you can build a prototype, simulate what you can build. Am I audible?
Yes, now we are.
Yes.
Yeah, you
Right.
cut out for a second.
Yes, my internet is a little unstable today, so it's buggy. So the main thing is prototyping stuff, so that you don't spend much money on building a prototype or an actual machine. But again, it is important to have this practice of virtual design sprints, where okay, if I want to build, let's say, a CEB press, I might know fabrication. Maybe Matt knows how the electronics works. You go back to your boards, you read about it, and then you come together over this kind of session, prototype it, simulate it, find the bill of materials in your local markets, or also find recyclable raw materials so that the cost goes down, and just simulate it to find out what exactly it will cost for you to build the prototype. And a prototype is a prototype. You're not actually selling it for any user, but you need to see if it is working. And once it works, then obviously you can productionize it. And depending on your interests and intentions, you can commercially sell it, or an enterprise, or a non-profit organization. So yes, sorry. So any questions until now? Are we making sense? Is it going in a good direction?
Yeah.
Cool. Um,
Saying yeah, makes sense.
Okay.
I see Ashima has also joined. Ashima, if you can quickly introduce yourself, and maybe Kalpesh, you can also try to introduce yourself quickly.
Yes, Prato, thank you.
Okay, cool. So Ashima is also based out of India, and she has a background of software engineering. She's here just for an observer, but she's more interested on the how this visual design sprint works. So there was another session that I had planned, which I couldn't take, but maybe Ashima, you can join that maybe tomorrow. Okay. Any other questions? Okay. So, so this let's move to the last section where can we build hardware remotely? And if yes, I mean that is an open question to all of you guys. With online collaboration tools, can we build a hardware? And if yes, how we might build it?
Yeah. So, I mean, I think from my experience, you can in limited degrees, but it's a lot more difficult than software. Um, like once you have the components and everything, kind of the prototyping um, phase can be a little bit design work.
Your voice is a little low, Matt. Can you come a little closer to the mic?
Yeah. So there's a lot of parallels between doing designing and building software online, but of course you can't do everything online. A lot of the design work can be done digitally. If you're building circuitry and hardware, you can do the design in different simulators and then share that around the world with other people. And so that'd be like the blueprints here. But then once you actually need to get out and build off of those designs, that's where it becomes significantly harder than software. With software, like ideally you just you download all of the code and everything, and then you just tell it to go build and it goes and does it all itself. But with hardware projects, that's when you have to actually get your hands dirty, and it starts requiring things like carpentry skill, where you can't just rely on the machine. Now with electronics, it's possible to just make your design and then send it off to several different companies that exist that will print up the circuit boards and send them back to you. Now a lot of the cheap ways of doing that would be having it built for you in China, where you just send your designs off to a factory there and they just print up whatever the designs are and ship you back the boards. But you can also find different local companies that'll do that for you too. Usually a little bit more expensive though. And also sometimes not as fast. So it is hard to kind of break away from using these more established companies to do the actual production of it, but it's still not quite the same as like going to a retailer, like having John Deere provide you with a full product. It is still a little bit more distributed, and it is kind of building it truly remotely. But with some of the tools in this, the open source ecology, those are well beyond just electronic circuit boards, and so there's no service that you can turn to kind of do the last production step of it. So the best you can really do is just online design collaboration. But then something that could help would be looking at that problem of going from whatever the design and the plans are and all of the steps of actually building it and what can be built to really help those steps, so that if I do have the design and I do have all of the materials, how can I make sure I go through all those steps easily without any problems, and that if I do screw up a step, how can I know right away and not go through with building an entire machine only to find out that like I put a gear in backwards and now nothing will work.
Yes.
Also, I think with the online design, again, going back to, you have to think holistically about how it might be received in communities that you're building it for. And if it does break down, how are they going to tackle the problem of building back up? And like you said, just the design of how can I make this as seamless and possible and write things down in a manual way so that people understand it. Because a problem that I see is like we come out of the States with these technology ideas and we go into one community and we have them almost use this technology as early adopters, right? Like maybe it's the solar panel or something in a community in East Africa. And then because we're coming out of Silicon Valley, we're just going to get more early adopters in another community, and we never really understand how that community is using these tools and what they understand about these tools and how to keep iterating. So I think part of online collaboration is really talking about how will people receive this? How can we pass along this knowledge or this information in a way that is packaged up correctly, or that they can adapt in their own way.
A very valid point, and to answer your Matt, you and even John, you also. Am I spelling it correct? Your name, John, Gian.
Yes, thank you.
Okay.
No worries.
So, you asked one question like how it can be built, right? Like you can, there is a lot of chance of you screwing up the hardware assembly or the welding or even the connecting of these components, because there is no, maybe you don't know exactly how to build a machine and you're just doing it, it's your first day, first time you're doing in your life. Not like software, obviously there will be bugs, but those bugs will can be fixed by piece of code. With hardware it is different, and it's the right point that you have mentioned, that is a barrier. But again, if I'm a mechanical engineer and I see the CAD designs, I it makes sense to me. If I'm an electronics engineer, I look at the circuit, it makes sense to me. If I'm a software engineer and if there is a software that I need to build for this running of these machines, making some part automated, that makes sense to me. If I know fabrication, so I didn't know fabrication when I built CEB machine few years ago, but read I could try to learn how for fabrication design from a CAD can be transformed into the actual hardware. So, for example, in CEB press, there is a storage at the top where you put the dirt, the soil beneath your feet. That is like a funnel. But how you design it in CAD took some time for me to take a grasp of it, with the dimensions, with the exact simulation of how it would be connected on the top and how the other parts will come together. Um, because I didn't know the knowledge of fabrication, I had to learn it from scratch. But if there was someone who would know it, then it makes more sense, and that collaboration actually will happen. Now, building it hands-on, yes, that is a problem. But if you go with open source ecologies, these things, there are videos that they have put. So I was trying to search for one video which they have put for CEB press. So for every product, they have a lot of documentation for every machine that they have. My internet is stuck, I don't know. But if you can find on Google Liberator CEB press assembly video, it is actually, they have made that video, put all the parts on the floor and started it from scratch, step by step, welding it, screwing it, everything. So that even Yes. So even if you are in a different part of the world where you don't have much knowledge, but you have the basics of it, you can build it by watching those videos. And obviously, with that as well, there is a room for screwing up, having bugs. But again, at least that reduces the chances of actually screwing it up for 100%.
Yeah,
Yeah.
yeah. And I think right now this is probably the
My
best thing to do is just get
You
some
can
very
see my screen.
Is the world's first automated
I'll
open source compressed.
Sorry, go ahead, Matt. I'll just keep the video playing in the background. It will take its time to load. Go ahead.
Yeah. So I was just saying that this is probably the best you can do right now is just like get these very detailed video instructions for this assembly phase.
Because I guess it's like with software, you can have a bunch of eyes on something and locate a bug together. But like if you're building hardware, it's just you and these videos.
Well, I would say the big difference is that like in the actual building of open source software that you're trying to use. And so that's very different from designing and like writing your own software. You don't have to know how that software works. You don't really have to look at that code. And so it's like this step of assembling, putting all the pieces together and actually getting it working, that's done by the open source project for you. So you just go, you download their code and you run one command, ideally, and then everything gets set up and is ready to use at that point.
Awesome.
And so
Out of the box.
and so that was one of the big advantages that I think really helped open source software come out, is that it was so easy to do every piece of the step without knowing anything. And that there's ways that you can make it very hard to screw up.
Nice.
And then it also doesn't cost you anything. You can experiment with new projects. You can go get someone else's code and run it, and you don't have to go and pay for actual assembly materials and then go through all of these steps to do it. And so that's one of the big impediments with open source hardware, is that it's not as easy to just pick up and play with. And so you have to find the people who are a lot more dedicated and have real need for it.
Yes, it is. Yes, you. Sorry to interrupt. You made a very valid point, Matt, and that the entry to even understand these hardware components is a barrier, because y- so if you ask me, I don't have a background of reading CAD files, how these are designed. So but again, with CED press, I got the CAD, got hold of it, just had to understand how fabrication works and use those designs out of the box. Now, just because my experience with that factory was they wanted to copyright and all that stuff, they modified some bits and pieces of it. But again, these designs work out of the box. Now, not all designs will be out there, so you will need to build some of it, and you need to have the knowledge of how fabrication is done, how a CAD design is done. So if I know CAD, I'll be a good contributor to this. But can we find those like-minded people? And that is the question. And that is where that prototyping comes in. Now, when it actually comes to building that thing, it can be done in different groups that you belong to in your local communities, or any organization that you belong to. It is, again, it's all on the interest and intentions. But right now there is no way for people like me to have a hold of, okay, if I want to automate something in the electronics aspect of it, I have my barrier is I have to learn it from scratch, and if I start now, it will take at least a year or two for me to gain that expertise, and then that is how it is delayed. So people who are interested can come online together, plan out these hardwares, and at least build the premise, the context, the pre-context of that particular hardware. And actually building that hardware is, again, in your own capacity. You can do it, or as a group you can do it.
Is there, with the open source ecology, is there a way that people are saying, hey, at this point in the steps, this is where we, like almost a forum of, okay, this is where I got stuck, and this is the problem, this is the solution, this is how we moved
Yes.
on? Is that being archived and available so that they can keep?
Yes, it is. So,
Okay.
one of the so you can read more about this on their website. But one of the most important aspect of this is you need to document it well, and they have done it pretty well. And that is open documentation, because if you need a CAD, you need to know how to even download that CAD, put it into free CAD or any other software, and make sure that you understand the nitty-gritties of it. So the documentation is well covered by open source ecology on their forums. On They have a Wikipedia, and many other websites where they have all the documentation. But again, it's not active. Like if you consider Linux right now, if I have an issue with even simplest thing like installing something on Linux, I can just go out there, and there are so many forums where there are people who have discussed this few years ago. I can just read about it and learn and just figure out how to install that software or do XYZ thing. This is pretty new. and the idea is pretty new for these open source hardwares, and that participation of people would actually build that forums. But there are pretty much good work that is being done in US and the other regions that I mentioned, and they are contributing to this website. So there is a summer internship that is coming up. I think the registration is closed. So it's more like if you have an expertise, you can just for a, let's say a 4-day workshop, you can just join in. If you are a videographer and you know how to build good videos, you can use that skills to document the video that we were watching, right? This is not done by one person. This is a team collaboration. And that is one of the aspects. There is a document manager role, which people rotate across online, even in their workshops in, I think it is Mississippi. I'm not sure the exact location of the open source ecology, but they have few people who come in and they get those roles and document it, build it, assemble it, test it out, and then they go back to their own jobs on their own worlds. So pretty much the documentation, at least with this aspect, is there. But again, if you want to build something new, you have to make sure that there is enough documentation. And today it is very easy to capture a video and just upload it to YouTube or other channels, and people can. So when we were talking about one aspect where there is no way these people can service these machines, so servicing, repairing, these are also some concepts which people can create documentation out of it, maybe a video or a PDF or a text-based documentation, which will help them step by step to disassemble and again assemble. So one of the practice that is done in these workshops in open source ecology is they will set a time, and if there is a compressed brick press built a year ago, maybe the second prototype, with the new people coming in, they'll disassemble it and again assemble it by watching these videos and add on to those videos to make sure that what they are learning is. So they keep improving iteratively on that as well, that front as well. So
And
yeah.
thank you for answering that. On the CAD, for those that don't know, computer aided design, I'm not really I don't know enough to know how that's a big barrier, like understanding that software.
Well, so yeah, it's like a way of, say, laying out any sort of 3D design. So in this case, it'd be like all the mechanical components of the machine. So a lot of those schematics get kind of complicated. Like you have all these gears and screws and bars and everything that fit together. And so it's all in this CAD file, but it's still like a strange 3D representation of every single piece. You have to know how that software works to go and like really manipulate that, view it, and to see what all of the pieces really are and understand how it fits together.
Okay.
Exactly. So maybe you guys have played with Legos as a kid, stacking those together and maybe building a tower or a car or whatever. This CAD is more like you're doing it in a digital way. You can assemble those pieces together and see the if it fits together, the dimensions will work out or not, and all that other aspects. So it gives you, so it is widely used across industries in building planes, machines.
Airplanes and things like that. Flying in the sky. Yeah. Okay.
Exactly.
Thanks, guys.
I have to drop out. It was nice. I'll catch you in the next one. And yeah, thanks for having me over.
Cool.
All right.
It was nice meeting you, Shashwat. Thanks for joining.
Yeah, likewise. I'm interested to know more. We'll keep in touch. Like I'll talk to John and get your contact and stuff.
Definitely.
Yeah.
Sounds good.
Yeah. Thank you.
Thank you.
Bye, everybody.
Yeah, so I think there's a lot of parallels that you can make between just kind of this and Linux, but I'd say the big difference right now is that, and kind of an impediment to the open source ecology plan, is that it's too focused on something that most people actually don't need, or at least most people in a position to do the contributions and a lot of the work don't need it. Like I have no use for a brick press, and it would be kind of hard for me to find the space to build and test one if I wanted to. And so with Linux though, it's not really about what it is you're trying to do. I mean, it's a critical part of like you need it to have your computer running, but everyone has their own kind of selfish motivations for contributing. They have this one thing that they want to build. And so they have to go in and figure out how to do that and add that back in. So I think to make a project like this really take off, I mean, of course, you still need the focus on the open source ecology, but to focus more broadly on open source hardware and find all of the little communities where people need hardware that doesn't exist, so that we can build up the tools for collaborating about building hardware, kind of across different teams remotely and across time. And that as we develop those processes and little reusable techniques there, that then the open source ecology can go and reuse those things to this specific purpose. It might be a little bit ahead of its time right now, in that there's no real open source hardware infrastructure for it to be building on, just in terms of people collaborating on these sorts of projects. That it's something that they have to now build out themselves too, is just kind of a prerequisite to what they're doing. I mean, they're doing a great job of it, but it's like they have to spend so much time prototyping, like, well, how do we document this? How do we make sure that we have everything really covered in building these machines? And that for it to become bigger, we need to find ways to include other communities who have those same goals, so that the work can be distributed out.
Awesome.
Yes. Yeah, I think, and just to add to what you mentioned, Matt. So again, if the more you experiment, the more you learn from this. So, like you were saying, like when these pieces are assembled together, there are chances that it might go wrong. So there was an experiment which was done. I had just joined over Hangout, Google Hangout. So the workshop was set over Google Hangout, where there was one machine, I think it was brick press only, which was built in US, and the other one was built in some other, I think it was Belgium, where they had a fixed time. Okay, today 10 a.m. we all meet over Hangout. We have all our materials. All the components are ready, because we met over a month before to plan it out properly, and then over the Hangout they were guiding each other, following those assembly points, attaching those things, seeing step by step if everything has been connected well and working out. And at the end, they were successfully. So it took them almost a day to do it. It was not a complete continued 8 hours or 10 hours session. It was like, okay, 2 hours we meet. Okay, this is the plan. We do something in next 2 hours. So these kind of stuff will also, so this was an experiment that they did, and it helped them. uh, People in US who are who are part of open source ecology, they have an expertise, so they were able to do it quickly. But people who were in the other part of the world, they were not able to grasp it quickly. But again, there was a online access support in real time to build this out. So again, there are many ways that can be experimented. But again, finding like-minded people, grouping them together, and then building out something is the challenge. Like you mentioned, I'm not interested in building the brick press because I don't have the use of it. But if you want to build it for someone who can use it, you have to find the right people to come together. I mean, it won't be you doing it, it may be someone else, but it's again, it's on your interest and your intentions. And again, one point I wanted to make is it is easy, by the way, to build these machines in India because of the availability of the raw materials and the availability of the labor. So I'm not sure how it is in US, but if I want to find a person who is an expert in welding things together, I have many people in my own network who know it, who are not software engineers, who are not mechanical engineers, but there is a lot of labor out there in the who are working in these industries, and they can just hop in and give you a good welded component. So uh, again, I go ahead and weld it, I'll be getting scratches all over my body because I don't know, first of all, how to handle a welding machine. uh, but if I have a person who knows it and guides me, I can learn it quickly. It won't take me 2 months to learn it, maybe 2 days or 5 days, I don't know. And that is what is important. So uh, again, hard to productionize, yes. If you're doing it for commercial purpose, then it has to be well funded, then you can obviously productionize it. If you want to do it for an enterprise or a non-profit purpose, obviously then you don't want to productionize it, but you will need expertise to build it out. I had one question, like when you guys were talking about can we build hardware remotely. I think maybe we can drop off in another 10-15 minutes. It's been a long time we are talking. Actually, I have to run for my dinner. My family is waiting for me. So one question that popped up when you guys were talking about can we build this remotely is there a, so me building these components from scratch, or maybe using open source ecology designs, maybe it is difficult for me, but maybe I can buy some off the shelf products and try to assemble it. Is there a possibility of that? Like, so for example, in the first prototype that was built by Martian for tractor, they bought a diesel engine from a there is this scrap yard, right? They would get a machine from there and try to fit it in, and they had the other assembly, the chassis and the wheels, and they could just run it. So maybe that is one thing, we can break on that barrier of actually building those designs from scratch by getting things off the shelf. And by off the shelf, going to John's goal of sustainability, using as much recycled components as we can.
Yeah, and
uh,
I think a really important piece for this to be practical, because like in many of the communities that need this stuff most, they're not necessarily interested in just like, oh, how can I build this all from scratch so that I have built it all myself. You know, they just want to get whatever it is done, and they're looking at, you know, whatever they have. If they have an old diesel engine, you know, if they have some old tires that they're able to get, rather than trying to figure out how to make a tire,
exactly.
that they're going to want to use what's on hand. And so, yeah, that's always going to be a really important component of all of these designs. Like, how can it be made so that it can accept most of these things? Like, can it work with any engine?
Yes, and actually, with that same thought, there is one experiment that I had seen. So in India, when I was researching more about why there is an issue with the farms that are there, why people are not getting enough from it, there were lack of tools. Now, I won't say every farmer in India needs a tractor, and every farmer cannot afford it. Even if you bring down the price, maybe he won't be using it, or he won't go for it. But there are small components, like there was a seeder which I found on open source ecology. I'm not sure if I can get the right image. But a seeder is basically you attach it to a bicycle and plow, like go on your field and start planting those seeds. You don't need
Oh,
a tractor for it. One of the guys, I read about this in India, had attached this to a, a bike, like a motorbike,
Oh,
and
nice.
speed up the process of seeding it. One of the guys tried to, not this exactly, this is, I'm just using this image for a reference. Um, but one of the guy used a bicycle, a normal bicycle that we ride in our when we were kids. Now I don't know if you guys ride it. Just removed the front tire and attached one of the components like this seeder, and he was able to. So tinkering is there obviously, but then they didn't have access to these kind of seeder. They have to buy it off the shelf. Now if I go ahead and make this seeder, I can do it because I understand the fabrication of it. And if I can make it out of scrap, or get some things from the scrap yard, I can make it so cheap that I can even distribute it to through a non-profiteering thing, or maybe build an enterprise. Or so that the imagination is, there is no limit for it. But again, finding the right it, there was a problem that I saw where people were struggling to seed. Now they are also struggling to cut their harvest. So in wheat, if you see, your wheat needs to be cleaned properly. And right now, if you've seen John Deere's machines, they have these huge machines where it goes in, the dirt goes out, and the wheat falls into a truck. But there is a way that can be modernized in a way, in a modular Lego type way, where you don't need a huge machine to just clean your wheat. You can be creative in that. Just give an example. So these kind of stuff can be brainstormed, but again, as you said, it all depends on the common interests.
Yeah.
I love the bikes because anywhere you go, people have bikes. That's their form of transportation. But even the bike, the washing machine, you pedal
Yeah,
the bike
yeah.
to get the washing machine going. It's really
Did you see that? Maybe you can Google it. And it was really interesting to see that she was like 13, 14 years old, and she saw her mother washing her clothes by hand, and it would took a lot of time, a lot of energy, and she could think of it and actually make it by herself. Obviously, her father and one of her colleague helped her build it. But again, at least having an idea is the first step. Next is the execution, and she could pull it off and
and that's
solve her own problem.
the kids too, giving them a voice because they're ingenious. And so in any community you're in, if you give this problem to a kid in a design thinking way and get their gears turning, they might, all that imagination comes from them often in these communities, and these stories that bubble up. Even the kid who's, they're like 16, maybe 13 to 19 years old, they have these ideas and they're like, let's remove plastic from the ocean giant net, make it happen. So I think giving them a voice too is really important.
Yeah, and I think as we grow older, we lack the dedication. We get more busy in our lives, I would say, maybe in our jobs. When I was young, I had a lot of ideas and a lot of energy. I do find it right now, but I have other responsibilities also. But again, there are people who at my age or even who are way older than me are putting finding time to follow what they love or what they want to do. So again, it's all about interests and the intentions that we have. Again, another question, like you guys were saying, so you don't need a tractor if you want to make this happen in South Africa or Kenya or any other region, because there is a barrier where people won't first of all buy it. Even if they buy, they don't know how to use it. But again, these kind of innovation where the seeder can be attached to a bicycle, it can work across the region. You don't have to build a fuel engine to power it. And addition to this, you don't need a. So again, going back to the sustainability goal, you can maybe electronize most of it. You don't need a diesel engine or petrol. Maybe use more of a renewable energy like solar power, and I don't know. I mean, you can solve the right problem. Again, the most important thing is the premise, finding the right it and then building it. So I think it was a very, for me, it was a very good session. I would say I have learned so many things from you guys. and I have good amount of points to maybe find out how exactly this might work out, and maybe we can connect more on this. But again, uh, this was the first session that we have connected on, and I hope it was useful, and I hope you guys have learned. So before we disperse, so I see Zach and Sindra are also on the call. So you guys have any questions? You want to talk about something? And maybe you can look at this retro and just give your feedback about this session as well as about the topic that we discussed.
Absolutely. Thank you, Prathod. This is all very new to me, so I'm like taking in time to sink it in. And yeah, I would like to collaborate with you and Jean and see how we can actually solve some problems.
Yeah.
Yeah, thank you for leading us, Pratod. We really appreciate it, and we're glad that we connected with you. And there will definitely be follow-up sessions. So, thank you.
Definitely. Zach, you there? Zach,
Yes, thank you for hosting this. This has been great.
Yeah. So one quickly, can you guys tell me what you liked about this session?
Yeah, it's given me a lot to think about in terms of the open source hardware. And I mean, now I'm thinking a lot about what the real barriers to adoption are. I mean, when we're talking about open source ecology, it's all focused on areas that more need a lot of this stuff, but where a lot of the work can be done would be places like over here in the US where there isn't as much need. So it's just kind of thinking about how to get the interests of the two crossed so that a lot of more meaningful work can be done here that can actually help the people who need it. So that was a great session, and it's given me a lot to think about.
And people to use these skills or improve their skills. It's like, how do we find people who are wanting to do skills-based projects and really talk about the motivations and incentives there to work on these things? So.
Yes. So anything that you didn't like about this session? So this whole, not just about the topic of building hardware, but also about this way of brainstorming on some topic or some idea, like the visual design sprint that we have today.
Yeah, most people came in with a different ideas of what they wanted to talk about and what they wanted to get out of the sprint. So that's what I would be kind of the negative, that there wasn't like a whole any sort of shared understanding, but it still came out to be a really good session.
I think we felt a little rushed at first because we thought maybe we only had 40 minutes, but as long as we plan longer sessions, I think everybody wants to participate in a longer session too. But I mean, I think that this session, I agree with Matt. This helps give us a common framework and mental model from where to work. So going forward, we'll get some more happening on these work canvases, so to speak.
Yes, and yes, it's a very valid point that you guys have made. And I also personally didn't like the fact that I was rushing into getting introductions and people adding notes and all. But again, that is something that I can improve on the next time. One thing that I personally, if you ask me, I didn't like is there has to be a conclusion about any session. I have good amount of points on this last column, but I'm still not able to conclude something. So maybe I couldn't ask more questions to you guys, or maybe I gave you guys more questions to think for. I don't know, but definitely next time.
I think that also kind of comes into not everyone having a clear idea of, meaning it's hard to come to a conclusion when you're just trying to catch up and understand everything that's being.
True.
I also think that Sorry, did you finish? I thought you got cut.
You're good,
Go ahead.
Sindhu.
Okay. Yeah. So I also thought that maybe this was kind of an introductory session on various topics. And if we focus on one single topic or, a couple of topics, we would be able to have a better understanding of the process and come up with a solution in the end, like the last points that you were talking about just now. Maybe because this is like an open discussion about various topics, it it didn't actually give you any kind of a solution or a last ending summary.
Yes, definitely, I agree with that point.
And we could also, like Sinju said, I kind of want to download this information and process it and then think of conclusions in, like, maybe individually we think about, so what are the next questions we have for the follow-up sessions? What are those? How might we start thinking about these individually offline, and then maybe type those up, and then
Yes.
decide what the next focus is.
Yes, exactly. And I think that leads to maybe having more sessions like this, more structured approach to this, more background for people to understand the agenda of this kind of session. And along with that, so it can be planned in a sprint way to just brainstorm on this and find the right it. Again, you can build the right premise in sprints, and you can also build the hardware or any other implementation that you have to do in the sprints way of doing things, that the way we do it in softwares. Now, so one of my friend actually was, so he joined in the middle, but he dropped off. He just WhatsApped me and he was saying, what is a sprint? So for people like you and me, we are well versed with the software way of doing things. So we could understand sprint designs. John couldn't understand what CAD was used for. So these kind of knowledge gaps would be there, but we'll have to make sure that Zach, you were saying something. I'm sorry, I saw.
No, I was just switching my audio. I have to leave the house, but continue, please.
Okay, cool. Again, so conclusive enough, good conversation, and I have few points to improve on this as well. But with more practice, I think I'll get a better session next time.
Yeah, facilitation, it's a process. I learned myself is that I think it's important for the team to have like a common glossary. So CAD, just definitions. What is CAD? That's computer aided design, for those people that may not have been introduced to that. And then myself sharing with Zach and Sindhu, like, hey, here's open source ecology. Here's the TED Talks. Here's kind of some preliminary stuff. This is what a virtual design sprint is. And then people can read those before
Yes.
joining the session. So I think we tried to do that. We could always
Yes.
I think a glossary type thing could be really cool as something you do during the
session
sprint. It's like if new terms come up and someone doesn't know the term, like, oh, what is that? Just have like a little glossary section, just like, oh, let's jot that one down,
Yeah.
so that after the fact you can come back and, like, if there's a bunch of stuff you were unfamiliar with, you have that list of things to go and start looking up.
That's a great idea.
Yes.
Let's do that going.
Yes, definitely. And so we just missed on one point of the design sprint, but maybe we can try this next time. So there is a lightning decision or a voting that is done on these stickies. So for example, maybe we might do it in our next session. So when we posted these interests, every individual has an interest. You can vote on which ones you also connect with. For example, maybe online collaboration. Maybe Zach has added this point. He wants to know more about how online we can collaborate. I think Saswat added this point. So maybe even Zach want to know more about how it can be done. Maybe Sindra also wants to know. So there is a dot voting method as well in the design sprint where we can prioritize, and based on, so by the way, this is a common interest that I see, and maybe we can host the next session based on some of the topic of this, like people want to know more about how online we can collaborate, so that can become one session. Hardware collaboration again is another session. We had a lot of things today, but again, it's on the interest of this audience and how we can make sure that we bring it on, map it out on one single canvas. So we'll definitely try to get our next session going on. It is not possible for everyone to join every time, but again, the common interest should be considered, and I'll make sure that I can give as much time as possible. Again, as I said in the initial session, I thought only Jean and Matt will join, and it will be only two of us, like we were talking yesterday. But I appreciate others also joining in and contributing to this. It adds to more confidence. So, any questions? Any last thoughts before we wrap up?
Nope. Thank you.
Cool.
That's
Thanks.
great.
Yeah, thank you.
Just one last question to all of you. Does it make sense to time box these meetings? So I initially did a 40-minute thing because I have a limit on Zoom, but what is an ideal time according to you guys? Maybe 60 minutes, 90 minutes?
60 to 90 minutes.
90 minutes. Okay, cool.
And when we have, I think that's part of just making sure, because we can go on so many tangents with this stuff because it's fascinating. Just making sure we stay focused on those topics that we're discussing for that meeting. But yeah, I think 90 minutes.
90 minutes, yeah. And after this call, I'll try to send out as much information as possible about the things that we have seen on this board. Like I missed on iShow, so maybe I'll add some URLs, what prototyping, what is virtual design sprint, and maybe you guys can do your own research. So cool. Thanks guys for joining this session, and I hope to meet you guys again.
Thank you.
All right. Thank you guys.
All right. Bye.
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 Have a nice day.
See you.
Okay, thank you, everyone. Bye bye.
Bye.
Bye.